This is Honors Geometry Lesson 8.5, Part 1, Properties of Trapezoids. So first of all, what is a trapezoid? A trapezoid is a quadrilateral, so we know it has 4 sides, but this time it has exactly one pair of parallel sides. So let's look at that. So our quadrilateral has one pair of parallel sides. The other sides are not parallel. If the other sides were parallel, then we would have a parallelogram. The sides that are parallel we call our bases. The sides that are not parallel we call our legs. Okay? So what's special about a trapezoid? We know if we have parallel lines, then our consecutive interior angles are going to be supplementary. So if we have 2 parallel lines cut by a transversal, we know we have CIA, consecutive interior angles, and we know they have to equal 180 degrees. And that's about all we can say for our trapezoid. If our legs are congruent on our trapezoid, then we call it an isosceles trapezoid. And that one's a little bit different. You can see the diagonals of a trapezoid are not going to be congruent. But the diagonals of an isosceles trapezoid are going to be congruent. What else is special about an isosceles trapezoid? If you can envision this as sort of like the bottom of an isosceles triangle. We know in an isosceles triangle our base angles are going to be congruent. The same is true for an isosceles trapezoid. The base angles are going to be congruent. In this case, we have 2 sets of base angles, and they're going to also be congruent. All right. So here we go. The base angles are congruent. We said if it's isosceles. So our base angles are congruent, and the converse is also true. If the base angles are congruent, then we know the trapezoid has to be isosceles. And the last one we said is that the diagonals are congruent if the trapezoid is isosceles. All right, let's practice. Okay, so we have our trapezoid. We're given that it's a trapezoid. We can see it's not isosceles. So the only thing we can assume is that our consecutive interior angles are going to be supplementary. So I'm going to take 180 minus 65, and it looks like our missing angle is 115. Okay, so same one for this. We can see we have consecutive interior angles, so we know they're supplementary. So I'm going to take 180 minus 92. So it looks like our missing angle is going to be 88. All right. The next set, it looks like they're showing us that these are isosceles trapezoids. So we know that base angles are congruent, so I know this angle is also 50. And I know that consecutive angles between the bases are supplementary, so I take 180 minus the 50. I can see that this one is going to be 130. And again, base angles are congruent, so I know that this angle is also 130. Okay, if there's 100 here, we know there's 100 here because we're given this as isosceles. And then we take 180 minus the 100. That means these base angles are both 80. All right, let's throw a little algebra in there. Okay, again, we're given an isosceles trapezoid. So if this angle is 51, I'm allowed to assume that this angle is 51. And I know together these two have to equal 180. So I'm going to say that 28x minus 11 plus 51 gives me the 180. Combine my like terms together. I have 28x plus 40 equals 180. Subtract 40 from each side. 28x equals 140. And then we're going to divide 140 divided by 28. And it looks like x is going to equal 5. Okay. Again, this is an isosceles trapezoid, so we know base angles are congruent. So this angle is also 12x minus 28. We know consecutive angles between the bases are supplementary. So I'm going to take this plus this and set it equal to 180. So I have 12x minus 28 plus 5x plus 38 equals 180. I'm going to combine my like terms together, 12x and 5x. I'm going to combine negative 28 and positive 38 and give us 10. I'm going to subtract 10 from each side. Divide each side by 17, so it looks like x is 10 in this case. All right, let's talk about the diagonals. We know that if the trapezoid is isosceles, the diagonals are congruent. If the trapezoid is not isosceles, then we can't assume that. Okay, so we're given Km. This whole thing is 22. So the question is, how big is JL? So JL also has to be 22. This time we're given F DF is 8.4. Again, it's an isosceles trapezoid. Oops, 8.7. And so the question is, how big is EG? EG would also be 8.7. Please try the practice problems. Let me know if you have any questions. Thank you.